Howdy folks, welcome back. So in this video I'm going to go through the no-calc portion for the Unit 4 review. So with no further ado, again, let's go ahead and get started here. Let's dive right in. Alright, so again, your vertical asymptotes. So if you have f of x equals 7 over x plus 10. Alright, so again, your vertical asymptotes are just going to be when your denominator equals 0. So you have x plus 10 equals 0. So here you can subtract a 10 from each side. So you end up with x equals negative 10. So that's going to be my vertical asymptote there. Alright. So the next one here, so you have log base 10 of 100 equals x. Alright, so again, to solve a logarithmic equation, so the logarithm is just saying what number I need to raise 10 to get 100. So again, we can rewrite this as an exponential. So again, we have 10 to the x equals 100. So 10 times itself, how many times equals 100? In this case, we have 10 squared is equal to 100. 10 times 10. So in this case, we have x equals 2. So the log base 10, or the common log of 100, is just going to be 2. All right. So this was, I think, just like one that we just had. Oh wait, we had 2/5 in the previous, calc portion there. All right. So again, when you're not adding or subtracting outside your exponential expression, then your graph is going to go through the point 0, 1. So that illuminates these last two here. All right. And if this number inside here is greater than 1, then your graph is going to be increasing. So so in this case, 5 over 2 is 2.5, which is greater than 1. So that's going to be increasing, which this one is decreasing there. So it has to be B on there. All right. So this one here, so 3 is just a graph. So we have log base 6 of x equals 3. All right. So again, this is just going to be 6 to the third equals x. So so we have 6 times 6 is going to be 36. So 36 times 6. So 6 times 30 would be 180. 6 times 6 is 36. So that's going to be 216. All right, so here we're asked to write this in exponential form. So we get exponential form. I suppose I can go ahead and write this down. So we have log base 64 of 8 equals 1/2. So again, we just take our base, raise to whatever power our logarithm equals, set it equal to what we're taking the logarithm of. So in this case, we have 64 to the 1/2 equals 8. Which is the first option here. All right. All right. So here to find the degree of your leading coefficient. First, I need to get the paper to where I'm at. All right. So you're just going to multiply the leading coefficients of each of your factors. So here I have negative 7x squared times x, so that's going to be negative 7x to the, so we have squared, times 1 would be x to the third, times another one would be x to the fourth. So my leading coefficient for this expression is going to be negative 7x to the fourth. So the degree is going to be 4, and the leading coefficient is going to be negative 7. All right. Zero. All right, so if you have a leading term of ax to the n, for the n behavior of the graph, we have the following options. So if n is odd and a is less than 0, so then your f of x is going to approach negative infinity as x approaches infinity, or negative infinity, sorry. And your f of x is going to approach, wait, this is less than 0, so this would be positive infinity, sorry. And then your f of x would be approach negative infinity as x approaches positive infinity there. If your a is greater than 0 and your degree is odd, then f of x is going to approach negative infinity as x approaches negative infinity. And your f of x is going to approach positive infinity as x approaches positive infinity. All right, and then if your n is even and your a is less than 0, then your f of x is going to approach negative infinity from each direction. So x approaches negative infinity, and f of x is going to approach negative infinity as x approaches positive infinity. And then if your a is positive, so if your leading coefficient is positive, then f of x is going to approach positive infinity from both directions. So yeah, so in this case, my coefficient is negative, my leading term is negative 7x to the fourth. So my a is negative 7, so my a is negative, and my n is even, x to the fourth. So that means it's going to be this. So it's going to approach negative infinity from both directions. All right. Okay. Negative infinity and negative infinity. All right. So yeah, so again, your vertical asymptotes are going to be when your denominator equals 0. So here we're looking for when x plus 4 equals 0. So that means that x is going to equal negative 4. All right, so then for the horizontal asymptotes, again, you're going to look at the degree of the top divided over the degree of the bottom as it really. You're going to look at the degree of the top as it compares to the degree of your denominator. All right, so in this case, they have the same degree. So in your horizontal asymptote, it's just going to be y equals the ratio of their leading coefficients. So negative 3 over 1, or simply negative 3. All right, and then again here you just got to kind of plug in values for x and see what happens. So yeah, so we have 0, negative 1/4. If x is 1, we have negative 3 minus 1 would be negative 4. And 1 plus 4 would be 5. So what if x is negative 1? So that would be positive 3 minus 1 would be 2. 2. And negative 1 plus 4 would be 3. And then let's try something crazy like negative 10. All right, so we have 30 minus 1 would be 29. And negative 10 plus 4 would be 6. Yep. All right, I think that should work. All right, so yeah, so here again, the degree is just the maximum exponent on your variable. So in this case, it's degree 2. And the leading coefficient is just the coefficient attached to that maximum exponent. So in this case, it's going to be negative 3. All right, so here we have negative 3x squared. So again, our a is going to be less than 0. Our n is even. So it's going to be approaching negative infinity, again, from both directions there. All right. So the natural log of the 8th root of e to the 7. All right, so I'm just going to go ahead and rewrite this with fractional exponents. So we have the natural log of e to the 7/8. And again, we have the natural log of e raised to a number. The natural log and e cancel out. So we're just going to have 7/8. All right, so here we can start out by factoring out an x. So we have x times x squared minus 56x plus 55 equals 0. All right, so here we can factor this. So I think we'll end up with x minus 55 and x minus 1. And then again, when you have a product equaling 0, you can just set each of your factors equal to 0. So you end up with x equals 0, 55, or 1. All right. So when you just have x squared, it is going to be a parabola. So that eliminates the middle one here. Here we have a positive leading coefficient, so it is going to be opening upwards. So that eliminates that bottom one. So then we just got to figure out what our vertex is. So the vertex, again, is going to be negative b over 2a. So we have negative negative 6 over 2 times 1. So our vertex is going to be x equals 3. Which over here, the vertex is negative 3. So it has to be that other one there. All right. So your y-intercept is going to be 0, negative 7. Again, your y-intercept is whatever your constant term is. And then here we have x squared minus 6x minus 7. Your x-intercepts are going to be where that equals 0. So x squared minus 6x minus 7 equals 0. So yeah, so here we have x, x. We have minus 7 plus 1. So yeah, so we have x equals negative 1 and 7. All right, so we have negative 510, comma, 70. All right, so next one here, so we have log base 16 of 4 equals x. All right, so again, we can convert this to an exponential. So you have 16 to the x equals 4, which 16, that's the same as 4 squared. So you have 4 squared to the x equals 4 to the first. So again, when you have an exponential expression that we raise to a power, you multiply the exponents. So you have 4 to the 2x equals 4 to the first. So again, when we have the same base on each side, we can just set the exponents equal to one another. So we have 2x equals 1, divide by 2. So you have x equals 1/2. All right. All right, so again, we have log base b of x equals y is the same as saying b to the y equals x. So here, my b is 6. We have log base 6. I'm taking the log of, so yeah, so my answer is 36. So that's going to be 36 here. That's my x in this case. And then my y is 2. So yes, we have log base 6 of 36 equals 2. All right, and again, exponential form is just the opposite here. So we're going to have 27 to the 2 equals 729. All right. Okay. All right, so here we're asked to expand this logarithmic expression. So here we're multiplying inside here. So we can separate that out into the log base 3 of 9 plus log base 3 of x to the 5th. All right. And then we have x to the 5th here. So again, when we have an exponent inside my logarithm, I can bring the exponent out front. So you have log base 3 of 9 plus 5 log base 3 of x, which the log base 3 of 9, so again, that's asking what exponent I need to raise 3 to get 9. So 9 is the same as 3 squared. So log base 3 of 9 is just going to be 2. So we just have 2 plus log base 5 times the log base 3 of x. 2 plus 5 log base 3 of x. All right. Squared plus 8x plus 4. All right, so this, we can factor out a 4 from this first part here. So we have log base 2 of 4 times x squared plus 2x plus 2. All right, and again, we can separate this product into the sum of the two logs. So we have log base 2 of 4 plus log base 2 of x squared plus 2x plus 2, which x squared plus 2x plus 2, that's x plus 1 squared, I think. That's kind of a jerk move. No, it's not x plus 1 squared. Can you simplify that at all? Oh, you can, because this is not a 2, this is a 1. Yeah. Okay, I thought that's what I was going for there. All right, so yes, this is going to be x plus 1 squared. Which again, we can bring the exponent out front. Log base 2 of 4 again. What value do I need to raise 2 by to get 4? So 4 is 2 squared, so the log base 2 of 4 is just going to be 2 plus 2 log base 2 of x plus 1. That's mean. Again. The math department writes harder questions than I would, but oh well. What can you do? All right. So evaluate this. So we have log of 1/9 of 81. So yeah, so we have 1/9 to the x equals 81. So 81 equals 9 squared, right? So that would be 1 over 9 to the negative 2, which is equal to 1/9 to the negative 2. So x should equal negative 2. All right, so yeah, so again, when you have the log of the same base as the base of your exponent, the log and the base of the exponent cancel out, so we're just going to have negative 2 equals x. So x equals negative 2 again. All right, again, we've had several of these so far, so we have 8 to the negative 2 equals 1 over 64. All right, so we're asked to expand this guy. So again, we have a quotient here. So when you have a quotient, you're going to take the logarithms, and then you're going to subtract them. All right, so here we have a product inside here, so we can expand that further as the sum of your logarithms. So we have the natural log of 11 plus the natural log of x to the 6th, and then minus natural log of y to the 6th. Again, come along for the ride. And then here we have an exponential expression, so we can bring those exponents out front. So you have natural log of 11 plus 6 natural log of x minus 6 times the natural log of y. So you have natural log of 11 plus 6 times natural log of x minus 6 times natural log of y. All right. So yeah, so when you have the log of a number that's 1 followed by a bunch of zeros, the answer is just going to be however many zeros you have. So in this case, so when you have the log of 10, you have 1 0, so that's going to equal 1. When you have the log of 100, you have 2 zeros, so that's going to equal 2. I think we had that one earlier. So in this case, we have 1, 2, 3, 4, 5 zeros. So the log of that is just going to equal 5 for the common logarithm. All right. Again, we already had an example of this as well. So yeah, so again, we have my base is going to be 10, and then I have a log base b of x, so x is whatever it equals. So yeah, so that's going to be, yeah, log base 10 of 37 equals k. All right, so here, again, we're just going to take whatever our base is, raise to the exponent of whatever a logarithm equals, and again, that's going to equal what's inside. So we have 128 to the 6/7 of x. All right, so yeah, so again, here it's handy to kind of know some exponents there. Most of these are going to be small numbers, so yeah, so you're looking at your 2s or 3s. In this case, 2 to the 7th does equal 128, so the 7th root of 128 is going to be 2, so we have 2 to the 6th equals x, which 2 to the 6th, so we have 2, 4, 8, 16, 32, so then we have 64. So yeah, so you have x is going to equal 64. All right. Minus 4 equals 0. All right, so first we're going to get, so we have the exponential expression all by itself, so we can add 4 to each side. So you have 64 to the x equals 4. All right, so 64, we can rewrite that as 4 to the 3rd, and 4 is just 4 to the 1st. So again, we have an exponential expression raised to the power. We have 4 to the 3x equals 4 to the 1st. So again, when we have the same base, we can just set the exponents equal to one another. So you have 3x equals 1. So you can divide both sides by 3. So you're going to put the x equals 1/3. All right, so again, your vertical asymptotes are going to be when your denominator equals 0. So again, we have x minus 9 equals 0. You can add 9 to each side, so we end up with x equals 9 for my vertical asymptote. All right, horizontal asymptote, so here the degree of my top is less than the degree of my bottom. So in that case, the horizontal asymptote is going to be y equals 0. And then again, here we just have to plug in values. So yeah, so we have 0. We have 7/9. Yeah, when x equals 1, we have negative. So you have 7/8. Yeah, because you have 7 over negative 8. Let's say when x equals 10, we have 7 over 1, or simply 7. And finally, if we have, we'll say x equals, we haven't done the negative number yet, we'll say negative 3. All right, so yeah, then we'll have negative 7. So negative 3 minus 9 would be negative 12. So we have negative 7 over 12. All right. Oh. The last test only had 25 questions, so I was like, all right, we're done. Not quite yet. All right. So yeah, so again, here it's handy to know kind of mainly your powers of 2. That's largely what these boil down to there. So 32, that's the same as 2 to the 5th. And 64 would then be 2 to the 6th. So we have 2 to the negative 5x equals 2 to the 6th. So again, when you have the same base, you can just set the exponents equal to each other. So you have negative 5x equals 6. So then we can divide both sides by negative 5. So you have x equals negative 6/5. All right. And here we want to condense the logarithmic expressions. So we have natural log of 4 plus 3 natural log of x minus 3 natural log of y. All right, so first I'm going to rewrite this 3 natural log of x and this 3 natural log of y. I'm going to bring these up to the exponent. So you have natural log of 4 plus natural log of x to the third minus natural log of y to the third. And again, when I'm adding, I'm going to multiply the arguments so it's inside the logs. And when I'm subtracting, that's going to go in the bottom of my fraction. So you have natural log of 4x to the third over y to the third. All right. So let's see how we did here. Uh-oh. All right. Review. Okay. So you have 0. Ah, that should be negative 7/9. Yeah. Negative signs, they'll get you every time. All right, I think everything else looks good. Yeah, so that should be a 0 and negative 7/9. All right, and I think that was the only one. All right. So again, hopefully you found this helpful. Again, on this question, since it's 4 parts, if you only miss one of the parts, I'll probably give you at least 1.5 points there. So hopefully again you found this helpful. Yeah, I think this will be the last video I have for this class. So thank you guys, and yeah, talk to you all later. Bye now.